Welcome to Study Loop.
Okay, so our player has the odds of Pgame of winning a badminton match. I'm just going to call that P for now, just because there's a lot of writing that's going to happen. And we're told that they can be declared the winner of a match if they can win 2 games, and there's a maximum of 3 games, right? So in the first round, they can either win or lose, right? And the odds of that happening would be P and 1 minus P. Okay, actually, I'm going to give myself a little more space here. Let's say they can win or lose, right? And the odds of that happening are going to be P or 1 minus P. Okay, and then from here, they could, if they've won, they can win again, win, or they can win, lose, right? Sorry, win, lose, not lose, win, lose, right? And if they've lost, then they can lose and then win, or they can lose and then lose again. Okay. If they've won twice, that's it. They can't do anything more. What are the odds of that happening? Well, it's P squared. If they win and then lose, what are the odds of that happening? Well, it's P times 1 minus P, because losing has the chance of happening of 1 minus P, right? So we could say the odds of winning and then losing would be P minus P squared, for example. Okay, losing and then winning, that's going to be the same. That's P minus P squared. And then losing and losing is going to be 1 minus P all squared. Okay, now we don't need to continue on from win-win, because once they've done that, they've won the tournament, right? But if they win and then lose again, then they can continually win or lose. So they can win, lose, win, or they can win, lose, lose. Okay, if they win, lose, win, right? Then again, we just take this and multiply it by P, so that becomes P squared minus P cubed. Okay, if they win, lose, lose, it doesn't really matter. We don't have to calculate that, but it would be P minus P squared quantity times 1 minus P quantity. Okay, and if they lose and then win, we are interested in continuing here. They can win. They can lose, win, win, or they can lose, win, lose. Okay, and if they lose, win, win, we just take this, multiply it by P. Again, it's the same as win, lose, win. It's P squared minus P cubed. And loss, win, lose, again, doesn't really matter. It's not going to be in our calculation, but that's P minus P squared times 1 minus P. Okay. So now, if we took P squared, and if we took, I'll just circle all the results we've got. The winning results I'll circle in red. Yep. What's going on here? Okay. The winning results I will circle in red. Okay. Win, win, win. Okay. And the losing results I'll circle in blue. Lose, lose, and lose, right? So the odds of winning the round in the tournament are just the sum of the red ones here, right? So that's to say that the odds would be 3p squared minus 2p cubed, right? That's the odds of winning a round in the tournament. And we shouldn't need to add this up, but the odds of losing would, of course, be 1 minus that. We could do that to confirm, but we'll see that that's essentially what you would get if you multiplied all of this out. You get 1 minus quantity 3p squared minus 2p cubed. Okay. So now we have the odds of winning a round. Obviously, I can't perform a Monte Carlo simulation in a video. You would need some kind of software to do that. You could do that in Excel. You would basically just make a conditional table like this and then run it a bunch of times based on what the value of P is. But what have you. But what I can do is draw a graph which shows the value of P match as a function of P game, right? Because P match, well, this is P match, okay? And these P games, that's what these are, P sub G, right? Okay. That is to say that if we graph 3p squared minus 2pg cubed, that's the shape of the graph. Okay, so overall, what this is going to look like, put 1 here, okay, it's essentially, I'll put 1 here, okay, looks something like this, okay, and then the rest of the graph doesn't really matter, but it's basically like that, okay. So this portion here is what you would need to graph. That's the probability of winning a match, right? So this is P match is the y-axis and Pgame is the x-axis. Okay, and we're just plotting this. You can put this in your graphing calculator if you want to see a better plot of it. Now, if you want to win a badminton tournament, you need to win 5 games in a row, 5 consecutive matches. And if that's the only path to winning the tournament, is winning 5 consecutive matches, right, then we know, right, that that their odds of doing that should just be P match, or sorry, P game. Sorry, rather. I mean, we can kind of step through what I'm talking about here. What I'm saying is, if you need to win 5 consecutive rounds or matches, right, then you can win or lose. You can win, and then win, lose, right? But each time you lose, you're just done, right? So we don't need to continue these trees. Say, okay, now you can win, or win, lose. You lose, you're done. Okay, so eventually the only winning option is going to be win, right? What are the odds of this happening? Well, it's just the probability of winning times 5, right? Right, it's going to be P match to the 5th. Okay, so what they want then is just a graph of P match to the 5th, or this function, 2pg squared minus 2pg cubed to the 5th. Now this plot is a little wonkier, but I'll just, okay, same basic idea. Okay, 1, 1, 1, right? And it's essentially this same shape, but super squished, okay? So what you end up with is, okay, the blue will be the part that really matters. Something like that. Okay, so it's right around 50 that it actually becomes, possible, and then it's very sharp right here. It rises sharply, but that's the plot.